Thanks for inviting me to this series of seminars. My name is Enrique Vivoni, and I will give you a small introduction about myself. This is the photograph taken when I became the dean, because I became important. And the photograph that I have in my website, it has a cap, and it's 15 years old, and a student told me, I saw your photograph, and I don't think you are the same person. So what do? I am a researcher, professor in 2 units. I'm in the engineering school in the area of environmental engineering and water resources, and we are in the School of Earth and Space Exploration, Astrophysics altogether. And there I talk about hydrology, and as an associate dean I'm in charge of a postgraduate studies in the international level that my university offers, and interaction with other countries. And we also carry out a great effort to disseminate and mobilize knowledge. And what we do today is part of a mobilizing knowledge that came out of a lab, and it's being disseminated. And I am in charge of the Office of Postdoctors. I have around 350 postdoctors, 21,000 students of postgraduate studies, and 50 of them are Mexican. I know math. I don't like those numbers. I have a group of research that's quite diverse. We have trained around 25 doctors, and this is the current group, and they are working in different interesting topics. Eric Scotto is Mexican-American, and he is building an external apparatus with a slope rain simulator, carrying out measurements in the desert under controlled situation. Eli Perez, he's a student from Sonora. He's doing gas exchange, CO2 and water vapor in the ecosystems of Sonora in the US as well, and in urban areas. Kristen Whitney, she is from Phoenix, and she is carrying out a hydrological model of the basin of Rio Colorado being used in the renegotiation of the agreement among the states on the amount of water every state receives from Rio Colorado. Sai Cheng-Wan, he did his studies in China, but he spent a year with us in a student exchange, and he is doing modeling of the city of Phoenix, the flows, the hydrology of Phoenix. And Mercedes Kinley is from San Luis Potosí. She's doing hydrological instrumentation in urban parks that receive irrigation, and she sees how much water is being lost in the undersoil due to the irrigation of those parks. And Zachary Keller, he comes from the northern part of Arizona. It snows there. Poor guy, there is no snow in Phoenix, and he's doing some studies on slope hydrology in the southeast of New Mexico. And George Silverman, he from Phoenix, he is working with our local water agency in order to provide projections on the impact of climate change. And this is our people with masters and PhDs, and I won't be talking about any of these projects. I just want to give you a background. I was born in Puerto Rico, and here you can see my dear island. I'm very proud of the people from Puerto Rico, because we took out a government without losing any life, without using weapons. And in fact, the governor that we took out was with me in MIT. He was my schoolmate. I never liked him. Let us leave it there. I trained myself in MIT, and later I went to New Mexico Tech. I was a professor there for some time. I met people such as David Raymond has come here many times, another very good hydrologists that trained me as a young professor. They told me how to do a good career. Then I went to ASU, where I've been for 10 years, and I have been here in CICESE and in the University of Sonora, where I have very much enriched myself from the problem of the border of the US and Mexico. I married a Mexican woman from Ciudad Obregón, Sonora. I was bored there in Ciudad Obregón, Sonora, because I got tired of red tecates and grilled meat, and I decided to knock on the door of Professor Jaime Garatuza, and I presented myself as a hydrologist. He copied myself. He told me he also was a hydrologist. The rest is history. There is a group of hydrologists in Litson that I have trained as doctorates. And one of the big things that we have done in Sonora and the institution is field experiences for cultural exchange and science exchange. This is a mixed group of Americans and Mexicans. And we are downstream of the dam of Novillo, which is very important in the state of Sonora. In the lake created behind the dam, there is a water line that with the new waterway provides water to the city of Hermosillo. Normally, because this is part of the Rio Yaqui, this water would get to the big farmers of Sonora. That conflict that appeared in the news shows that generated a local political chaos, including that we were invited to the baptisms of the kids, and now we are not so much invited, and now we have a system of Sonora jazz and the government, and that's one of the reasons why the governor of Sonora was taken to jail, Padres, and we presented all of that to these students visiting agencies in Hermosillo and agencies in Ciudad Obregón that taught us, that showed us the same graphic that had the opposite argument, the use of science for other purposes. And we also did field work with this group, so here we have a list of the type of work that we have carried out in these field experiences. And I have always seen environmental sciences as a link for culture, especially across the border, where we share the system that is similar, and ecosystems that are similar, and the quality of air and so on. Okay, so I will be talking to you about the border. In general terms, all the border, it's a study of many states, and in all the northern border, as you know, there is an arid weather and there is a population explosion. Maybe you are considering going to live in the new cities of the borderline, but there is not only a growth of the population, but also a growth in agriculture and intensification of livestock, given by the economic conditions that are favorable after signing NAFTA. And these factors, as I said, give us to the pressures on the water resources in an arid area, and there will be also impacts to the primary sector and ecosystems, and finally to society. How many of you have gone to the north of the country? Very good. It's very diverse. If we talk about Tijuana, it's very different from Ciudad Juárez and very different from Nogales, and it's very different to Laredo. And we will try to consider the whole border in a homogeneous way using consistent tools. The tool we will be using is the hydrological modeling, and we will be using data of a remote perception to give way to the hydrological model. And here I will give you some of the context in order to see the results later. If you didn't know, there are deserts in North America. And these in orange are the warm desert. It has another number, but depending on who you talk to, it can also be classified as the Sonora Desert, the Chihuahua Desert, and this is the Great Basin. In English, they do not have specific names, are semi-arid, and they have an important cold season. The desert of Sonora is one of my greatest passions in the planet. First, because my wife comes from there, I live there, and the desert of Sonora is fascinating. Why? Because you have enough rain, season rain, in order to generate interesting ecosystems. Chihuahua Desert, I've worked there, I've lived there, is not so interesting. Let us leave it there, because people from Chihuahua here could feel insulted. And in that cross-border line, if you see this line of the border along all the border is desertic, but when I was in Cicese, I realized I was not in the Sonora Desert, but it's an area where the rain is few. This Pacific coastline is very interesting also. In all this area, we human beings have carried out dramatic changes, water extraction, installation of wells, we change the course of the rivers, we extract the water of the rivers, we pollute the waters and the airs and so on. When we see the hydrological cycle, we see things that we never thought were important. I live in the desert and I am going to water my grass. Why should I do that? Using water for irrigation, and that has an impact in the thermal condition outside of my home. That has an impact of relative humidity outside of my own home, and that type of effect is one of the many effects of the things that we have carried out in our rural and urban areas. And if we see the area of understudy, what you see here is the area under study, how to run a hydrological model in all the zone. We chose it with a certain criteria in mind. Basically, it ends in the border of Arizona with Utah and New Mexico and Colorado, and it takes part of the South California, including an important agricultural area, and we want to obtain in all Mexico, but we didn't want to cut Texas in half. So we established the border around here in order to include the whole of Texas. And here we decided that Guadalajara was the top part of the semi-arid area for our studies, Zacatecas, San Luis Potosí, Durango, Coahuila, Nuevo León, Chihuahua. We wanted to include all Baja California, but within here we have the Wilson we have the monsoon area, but some other areas that are not so. And let us run a model with the resolution of 6 kilometers in this area. Hundreds of thousands of pixels, and we will classify the vegetation and the use of soil using the Lancet images in 3 different periods, and these images have been classified by each one of the governments. The US government, the volume changed or it improved. Thank you. The U.S. government, through the Geological Service, carries out classifications of the use of soil. The Mexican government does it through INEGI. If you look at the border, that classifications are not consistent. We are deceiving ourselves. We have to be consistent in the classification of use of soil between Mexico and the U.S. was hard work. But what you see here is the final result. So you don't have to do all of this again. All the data I will be presenting to you are public data that are in zenodo.org. And this presentation will be available. You can look for our articles. At the end of each article, you have the link of Zenodo, and you can download the data with the instruction on how to use it and the limitation of the data. Here we had to carry out reclassification. If the US calls it matorral and we call them bushes, but it's the same plant, let us call it bush. And this type of things. I want to show you 2 important colors for the rest of my work. Red are cities, and yellow are agricultural areas. So first, look at how big American cities are. The areal extension and the complex was Dallas-Fort Worth, Houston. We all know that LA and San Diego are together. So where is Hermosillo? And it's a little tiny dot. Ciudad Obregón is not present in the map. Chihuahua? Guadalajara, you can see that, and obviously Monterrey. But these are densely populated cities. The U.S. cities are less dense and less expansive. This is an important point for this discussion. So the hydrological model that we ran is not a new model. It's a model that is 30 years old, but we have had to modify it so it works for these arid and semi-arid areas. I will explain to you briefly. The hydrological models work in the following way. The rainfall is an inlet, and everything is conditioned to the meteorological product. If that is bad, the simulation will be bad. We are not simulating rainfall. It's a rainfall entrances, winds, and so on. And the hydraulic models have different levels in the subsoil, different layers, layer 0, 1, 2, 3, and the layer for the canopy and the plants. In each cell of 6 kilometers times 6 kilometers, we will have fractions of different uses of soil, the type of ecosystem 1, urban, ecosystem 2, and so on. And there is a series of equations that will divide the energy of the sun and the energy of the rainfall in the different heat flows or water flows. For example, the components of the perspiration, different components of the balance and radiation balance of energy. Clearly, there will be water flows in each layer, and a production that comes from the surface or the undersoil. Consider that if it was an aquifer or a very shallow aquifer. And this model that is called a big variable infiltration capacity has been used in Mexico previously, and in fact it is the way in which many projects are carried out in the US. And these studies many times include US and Mexico. The monitors of the drought that have a component of the humidity of the soil use this model in order to generate maps of the humidity of the soil that are used for the drought monitor. And we have also used it for studying the climate change and the new uses of soil. And I will show you an example. The simulations we will carry it out are in this period, 1980 to 2013, and they will be using the uses of soil of 3 different periods. At the beginning of the 90s, before NAFTA, 1 year after NAFTA, 2 years before NAFTA, and 2000 and 2010. The VIC model is open. You can use it, you can download it. And also within the GitHub, we show the different developments of the model, so you can look at the changes that have been carried out in the model. It's a public tool. Our work with the model is not from 94, because I was very, very young in year 94. More or less in 2006 we started using the model. I have carried out hydrological modeling with other models, but this is really a very good one for regional studies. We added a component of a low perspiration in arid zones. We included agricultural areas with risk, and we have a model of urban impacts, and recently we have generated parameters for the US, Canada, and Mexico that can be used in this model, and that are parameters of rain and parameters of vegetation coming from different sources. These are public data, again, in this study of the Journal of Hydrometeorology. We carry out water precipitation forcing. These models need a large scale for the time. We solved that problem more or less approximately. And then the MOLIS data for the parameters of vegetation. vegetable coverage, and so on. This was released last week, scientific data. These are open products that you can use for your own studies. Okay, some examples before going to the model. The model requires, as I said, we developed a sub-model of irrigation for agricultural areas. These are the most important irrigation areas. Central Valley of California, at least the southern part of it. Who knows what this is here? Imperial Valley, very good, and the Valley of Mexicali and San Luis Rio Colorado. My dear Obregon, the Yaqui Valley, Sinaloa, okay. And these are the agricultural areas of Texas and Oklahoma. What we show here in the colors is the percentage of a cell of 6 kilometers times 6 kilometers, or the section that is under irrigation. One means the cells that are entirely for cultivation and irrigation. And we carried out a model of the use of water in the cities. And this is based upon the census, how many people are in the city, what is the density of a population, and how much water is consumed per person in each city. So this is the intensity of water usage in the American and Mexican cities. LA, and you have Disney here, because you have gone to Disney and they use lots of water. We should look at Las Vegas. Las Vegas, Phoenix, Ciudad Juárez, El Paso, Dallas, and Hermosillo. A sub-model of the urban usage of water. Cities grow from year 92 to 2011. That means there will be a change in the urban water use. Let us look into that in the future. And the same agricultural areas can expand or can collapse. And both things have happened. In this period after NAFTA, the coast of Hermosillo, that was a great producer of citrus, collapsed. They affected the aquifer in such a way that they get brine from the sea, and these become non-productive lands. And we will look at the collapse of the area of the coast of Hermosillo. A little bit of the data. I give you all of this. You need lots of information to run such a model, and the results will be very rich in terms of the information that really gather and synthesize the data. And here we are looking at meteorological data and examples and the data of a vegetation. And in these three panels, we have the annual waterfall, millimeters per water, the rainfall during the winter, and the rainfall in the summertime. And in red color is more rainfall. Blue means less rainfall in these maps. Here we see that in the Mother Mountain Range we have an amount of water. In Imperial Valley, very, very little rain. It is distributed differently in the wintertime. The Mexican Pacific Coast in Baja California, that is the rainy season. When I lived in Ensenada, it rained every day in the winter, and we had a lot of pitfalls on the road. And after 2 weeks after Christmas, they put a Christmas tree on the pit hole, so the municipality realizes how many we have. And San Diego, Ensenada, Tijuana in the winter time. There is not much happening in winter in the continent. In the main continent, the rainfall occurs during summertime. Leaf area index. And yearly and in different scales gives you an idea of how the amount of water varies in the canopy. And these are cone trees, and when you come down from the mountain, it becomes subtropical bushes. And here we have cone trees, and everything in blue is bushes. And again, the data are available. You can use them, and if you can, please use them. How the area has changed from year 92 to 2011. Again, these are Landsat data that are classified, homogenized, and here we will look at the changes in the use of soil in agricultural and dry lands. This is around 20 classification of use of soil. In green color, that is an increase, because these are differences from 2011 minus 1992. And if you see a green color, it's an intensification or a change towards less agricultural area and bushes. Lots of green in Mexico, values near zero in Arizona, New Mexico, and California. If we see in the US, they increased the agricultural area in 1,000 square kilometers in that period. In Mexico, 18,000 square kilometers became agricultural areas. Where does this come from? From natural ecosystems converted into agricultural land. So this is a huge area. And this is in all the zones. If you look into these categories, the irrigation area, because there could be agriculture without irrigation. In the US, they reduced the irrigation area in 4,000 square kilometers during this period, and in Mexico, they increased it in 6,000 square kilometers. So US is doing something with that water. And in Mexico, we cannot obtain that water anywhere. So let us look. In terms of the urban areas, in the US, there was an increase in 16,000 square kilometers in urban areas, and in Mexico, it was increased around 3,000 square kilometers. You can imagine that here we have the greatest part of Tijuana and Ciudad Juarez. Well, that is a boom of the maquila industry and the internal migration in the Mexico going towards the north due to the maquila industry. And we can stop there, and it's interesting, but we would be speculating if we do not run the hydrological model in terms of the impacts to the water use. And that is the next thing we will be talking about. Before going to the result of the changes, let us make a small stop so you believe me that a hydrological model works, because if a hydrological model does not work, well, what are we doing here? And how can we prove that a hydrological model works? Because the area is huge. It's a huge extension. The measurements are limited. And we are talking about two countries with two very different measurement systems. And that is a period of 20 years or more. So let us look at 2-3 ways of looking at that one. Each one of these stars is a tower of a meteorological flow, and some of them just were there for just one summer. In Sinaloa, we did a measurement in 2004 only once in Sinaloa in a cultivation. We obtained the data. Let us use them to prove the model. In La Paz, Baja California, that meteorological flow tower has been there for 15 years. San Diego State and Sitmore collaborate. Some of these towers are in the pine tree woods, some other in the bushes, in the savanna, and some in Sonora. There is a great presence of this type of towers in Sonora, because they have been doing it since the 90s. The scholars of the university and the Technological Institute of Sonora, we set a group of all these towers profile, all the existing towers in the US. We carried out a comparison of low perspiration with a model, and we saw an example of one of these comparisons for a place in Arizona. The red dots are the observations, and the addition of colors is the model, but here we have a division. The low perspiration coming from the breathing of the plant in green from the naked soil, in orange, and the evaporation of water in the canopy of the plant. And that is, the model produces these three ways out, and you add them and you can see that in general there is a good reproduction for the station of summertime that starts at the end of June and ends at the end of September. Then we carried out a comparison of our product, our modeled product, with a product of satellite images, and I don't believe that satellites are so good, but well. There you have a product of low perspiration, and we carry out a comparison in a study about this evaporation perspiration field. And this is important because in this area it is between 70 and 85% of rainfall. If we have the good data of the flow, you have the hydrological cycle well, but other 5 to 15% of rainfall, it is reloading the aquifer, the water table, or it leaks through and arrives to the rivers. We also did a little bit of a validation of our model of irrigation area. What are we doing? We are looking at satellite images to see how the irrigation areas change along the year, because almost always in this area we have two seasons, winter and summertime, and when the area of irrigation expands or reduces, we apply more or less water. Data of remote perception validated in this case with the reports of Zagarpa of how much was the area under irrigation, and here you have it year 2000 to 2010 for different districts. This is Río Colorado, San Luis Río Colorado, Sonora South, Ciudad Obregón, Sinaloa North, the northern part of Sinaloa. The observations come from Zagarpa, and these are our estimates, the dotted line. It's our simulation, our perception of the remote area. I emphasize in this observation, in this simulation that occurs in year 2004, the Yaqui Valley almost collapses as an agricultural system due to a lack of water in year 2004, and there was an important reduction of the area under irrigation. And we can wonder why. For that we need biophysics, and another part is sociological. And we are talking about an irrigation district that, instead of being very conservative with their water, they took lots of irrigation from 2000 and to 2004. They made the system collapse. They used too much water. Another validation we have done is how much water is being used for agricultural areas. Recorded here, it means recorded by the governments that have an estimate of how much water is being used in agriculture per state. Here we have different states of the nations, Mexican and the US, against the simulations of our water use in the model, and many of them in this region correspond very well. We have some examples that are very outside of the line 1-1, and we understand why. These do not have an important impact in the results. So now let us go to the main results and their implications. And this is one of the 3 slides of the main results. And here we have the change in the areas of agriculture under irrigations, and the changes are from year 2011 minus 92. A positive value in blue means that there were more agricultural areas in year 2011, with a negative red value means that there was more area under irrigation in 92. Sinaloa has the boom for the production of tomato, green vegetables, and where is all this product going to the US market? The Yaqui Valley is suffering in this period. The Yaqui Valley, the history of Yaqui Valley is very interesting. The production was very important in the 80s up to the beginning of the 90s, and it falls dramatically, as I told you before, in the decade of the years 2000. So that relates to the amount of water that comes through the Yaqui River. This is the coastline of Hermosillo, and we talked a little bit about its collapse in the same period. There has been other collapses in Saltillo, Coahuila, and there are places where there is, and they have extended the use of irrigation, especially in Chihuahua. Be worried about your friends in Chihuahua. I went to Chihuahua City 2 months ago and I was very impressed. There's lots of economic development, lots of wealth. It appears to be, but this is an agricultural wealth using non-renewable underground water. So here we have a problem, and that is a time bomb in the state of Chihuahua. Minimum people in Sinaloa have rivers that with every monsoon they fill up their dams, but in the north of Chihuahua that cannot be done. And here we have this small graph that tries to be a summary of what is going on by country and by use of soil. U means US and M Mexico. If you are on the zero, the area increased. If you are below the zero, it is a reduction of the area. So these are the American cities that are increasing in this period. And these are the Mexican urban areas, also increased, but much less. The Mexican agricultural area and the agricultural U.S. lands, and here we have the consequences. And the forest, and these are the Mexican forests in the north of Mexico. And that is another part here. Natural bushes, and natural bushes in Mexico reduced quite a bit. So these agricultural areas are expanding to areas that were savanna or natural bushes. And you look at the situation in the US. This is one of the hydrological results, the changes in the evaporation, and again from 2011 less. 1992, if it is blue, the evaporation went up. If it's red, it went down. Much more evaporation in Sinaloa. Many of you are scientists of the atmosphere. If we are injecting water vapor to the atmosphere through the evaporation of a cultivation within winter-time or summertime stations that are used for agriculture, if you are outside of the greenhouse, that could be considerable. If you are outside of the greenhouse, it will have an impact at least to the shallow atmosphere. The same here, a very desertic area. You are carrying out an injection of water vapor through using irrigation for the cultivation. Some areas are reduced due to the reasons that we previously discussed. First example, water use. The change in the use of water adding agriculture and urban areas. Well, here things become complicated. A great increase in the use of agricultural water, mainly increase of agricultural water, so not a less use of water because the agricultural areas are tumbling compared to other decades. And here in Phoenix we have both colors, red and blue. What could that mean? We would have to see the conversion occurring in Phoenix happens in two ways. An irrigation area was made urban area. Irrigation agriculture uses more water than a residential area. You save water in this conversion. So the areas that are in red are places that were agriculture and now are urban areas, and we are saving water. In Phoenix, in the red area, the little parts in blue is when the urban spot goes to an area that used to be natural before, an area of bushes or a savanna that was not consuming lots of water, not consumes water due to urban reasons. And these different types of changes can become very complicated, and here we carry out a summary. In the US, the area increases in the urban areas, but the American urban areas consume very little water, and therefore these are around 50 millimeters per year. So the urban area consumes water. We know this by the census, the type of people, and the patterns of water consumption of each person. American cities are growing, but they are growing towards the use of water that is less than what used to be before agricultural areas. And here we have a decrease in the agricultural water use in the US. Agriculture uses more water, 350 millimeters per year. This a difference between 50 and 200, that are 192. This is the saving in the US thanks to the conversion of soil use provoked by NAFTA, among other factors. The US is saving water in these 30 years, and Mexico is losing water. Mexico is increasing the urban areas that use more water than the American ones because they are more dense, and they are also increasing the water use in agricultural areas. So there is a cost for Mexico, for this part of Mexico, of around 20 millimeters per year. What happens? That increase in Mexican agriculture is exactly in the places having been identified by CONAGUA. These are the impacted aquifers in Mexico. Some were affected in such a way as in Coahuila that they do not produce so much evaporation and they do not consume so much water, the same as in Sonora. Others are new areas for agriculture, and they are occurring in places under risk. In terms of the amount of available water in the aquifers, and that has to make us think of what are we doing in the US and Mexico, especially in Mexico, with the water use in the agricultural areas, and how that will make an impact in the long run. Once that you end up the aquifer, these are areas of non-renewable water. Reloading the aquifers is very slow. If you deplete the water in these places using isotopic methods, the water is 10,000, 12,000 years old. This occurred during another geological period, and you have to start thinking about it. And then, what are the implications of these changes in the Mexican society, in the American society, and in the interaction? We prepared a table that summarizes everything we have seen, and I want you to pay attention to the lines in color. And this is divided by urban changes, agricultural changes, and the addition, and in each one of them you have year 92, 2011, or the change at the delta. The area of the soil in each country, the water use in each country, and the total. The units are square kilometers, or this unit that makes us feel fear. Cubic kilometers of water per year. That's a terrible amount of water in the US. These are minus 2.7 cubic kilometers per year that are consumed thanks to the fact that agricultural areas have been withdrawn to make them urban areas. In Mexico, there's 3.2 cubic kilometers of water additional to what was used before, because natural areas were converted into agricultural areas, and that the difference is minimum between these two numbers, and it seems that the NAFTA carried out no change except, if you notice, in each country, because here we have a important saving, and here we have a depleted aquifers or rivers, and the rivers, the binational rivers, are regulated. Rio Conchos is regulated. Mexico has to send a certain amount of water to the US every year, and Americans pay lots of attention to the coming of this water. And who regulates the aquifers? The ones that are in the border. Who regulates them? And where is all the product going to? The product of all this water. Here we see that water was used for food production, and this food cross a border or are nationally consumed. Some of the uses of water for livestock in Mexico is consumed in Mexico, because in this period the rates of meat consumption are increasing. We are more used to eat meat, especially in the north. Some of the products cross the border to the US. Some products of wheat go to Italy. Italian pasta comes from Ciudad Obregón. If you didn't know, I tell you. They pay well for the wheat of Ciudad Obregón. So here we try to carry out a summary of what is going on. For Mexico, the US, every year, water is being used for other cultivations, for livestock, for fruits and vegetables of exports and domestic use, for exportation wheat. And here we have lots of information, but what summarizes it is that Mexico is exporting fruits and vegetables to the US and Canada at 0.4.8 cubic kilometers of water per year. That is the water being used to generate the tomato that goes across the border. Also, a cost of the land between 2,000 to 4,000 square kilometers is for the production of exportation tomato or wheat. So this is a virtual change of water, and also the export to other countries, as I said, Italy, for example. In order to generate these flows, and there is also it generates money that comes back to Mexico. We are not so, well, we cannot play the being a saint, but to consume this resource means to export kilometers of land and to export cubic kilometers of water from this country to another country. So this is the result of the NAFTA. This was considered when they signed NAFTA. They considered this when they renegotiated NAFTA. They consider this when there is a tweet on the North American Free Trade Agreement. It's utterly complicated. We have seen a small part of the problem from the point of view of a group of hydrologists who know something about models and remote perception and soil use, but we need to add up other disciplines, experts in bilateral exchange, people who know a little bit more about agricultural systems, people who can define better the use of water in urban areas and so on. This has so many social dimensions, economic, political dimension, biophysical ones, and we have not even talked about the atmosphere. Here we have a real flow of water vapor from one country to another, and it's being affected by this changes in the use of soil. If we want sustainability, not only in the US side, because Phoenix looks very nice, but as regional sustainability, then we have to realize that these free trade agreements have created externalities to a system, to a problem on the one side, exported to the other side. And this is exactly what this image shows to us. This is an American military base in the side of San Diego, where nobody dwells apparently, and this is the side of TJ, where we have all of those who work on the other side, who cannot live here due to migratory reason, and because it is very costly to live in San Diego also. So this is part of today's motivation, is that we unite farmers, scholars, people who live in both sides of the border. This was financed by Fulbright, CONACYT, the National Foundation of Sciences. Here we have the work of many people, especially Peter Bone, who was in my group first, and then he was a researcher in another group, other professors from SU, Litzon, the Colegio de Sonora, and the University of Sonora. This is a photograph of the Yaqui Valley. Here we have one of the thousands of kilometers of trenches for water distribution, water collection, and that is wheat. And this is a wintertime cultivation in the Yaqui Valley. You can see 50 kilometers away because there are no buildings, and you can see small houses once and every time in a while. It's a very impressive place. And the topics we have touched are postgraduate topics here in UNAM and other universities. In ASU, we have a good group of hydrology, but we touch on these topics. Hydrology comes from a set of postgraduate topics that can contribute to this: computers, political sciences, public policies. We need people in that area who could help us to carry out improvements. Hydraulic engineering, geology. And maybe I leave this question with you so we can talk a little bit. How can we strengthen the links between UNAM and ASU, Mexico and the US, to give a solution to binational problems that depend on the public policies of two countries that sometimes do not talk to each other? They have to love each other because truly they have the same climate, the same land, common history, culture in common. I leave this to your consideration, and this is a photograph of a Rayon Sonora of a monsoon storm. Carlos and Arturo have come to this little town. We have carried out a scientific collaboration between ASU and UNAM regarding the monsoon. The question is, how can we tackle as institutions these big binational problems? Thank you so much for your time. Do we have time for questions? Thank you very much for your wonderful presentation of such a complex problem. Congratulations, Doctor. It has been a very interesting talk. Really, to talk about our border is the most dynamic border. It's more than 4,000 kilometers with the largest economy of the world. How much do you know now with the TMEC? Not too long ago, we had a group of Democrats in Mexico to visit our executive, and in the interviews in the sidewalk that they did to them, they said that maybe it's not going to be signed this year due to the elections process there. The other thing is, let us talk about water, because that's a serious problem in both sides. But that was all that was said. I'm talking about the Democrats. And Pelosi in the New York Times said that we will adjust the TMEC many things could change, but how much do you know? For example, in our case, because here in Mexico, not much is said. It's incredible, but we know very little about this. In what situation are we? Because water is a serious problem. And the other point, migrants. Recently, the Colegio de la Frontera Norte and the Dean, before, if we talk about 30 to 50,000 migrants who come from the borderline, in all the borderline, and that will bring a problem with the water in the cities. That's why the problem of the governor of Sonora, because he said he built his own ways, his own water dam, so now he's outside. And thank you, doctor, I congratulate you. Thank you for your question, and you see why this topic is so interesting. It tackles all these social political topics. I'm not in the political sphere. The very little I know, there is a very strong lobbying in order to sign the new TMEC in the American side. You already approved it. It was approved here. You already signed. How that happened so quickly, we are surprised. In the side of the U.S., the lobbying comes from Vice President Pence to the Chambers of Commerce. And we had a first meeting in Arizona, Mexico, and there was a very strong lobbying process. That was a meeting of politicians, industrials, and scholars. There is a very strong lobbying in many sectors in order to accomplish this. If we are to accomplish it or not in 18 months before the new elections, I cannot tell you. We consider these topics. When they say the topic of water and they say TMEC or the new things, we see that they are completely hand-tied. What message am I giving to you? I tell you that NAFTA benefits the U.S. in the topic of water. It does not benefit you whatsoever, and that cannot be compensated in any way, so I leave it there. I have an announcement for those to prefer questions in a written way. And you go to Menti, M-E-N-T-I, menti.com. Ahí son noticias falsas. Oh, well, hopefully not. With the code 681839. Congratulations. I have two questions. One is a little bit technical, and the other one for your criteria. The first one relates to the resolution of the model. It's 6 kilometers. That would give me around 5 cells times 5 cells to cover Mexico City. And the thing is, this type of models, as you expressed them, implies a water flow in the surface and another water flow in the deepest part at the sides, and I think it also implies a vertical flow. Those simulations depend on the diffusion. A question that we have presented to hydrologists next door is that we do not know here in Mexico City what type of coefficient to use, because I do not think it's the isotropic one. It's going to be a mess how the chaotic part of that is included. If you could please tell us how certain are your results, or if there is previous modifications, because the satellite data show important differences and your results depend a lot on this type of coefficients. And due to what you showed us, the problem of water, and then I go to my second observation. Talking to Dr. Blanca Jimenez, current director of CONAGUA, she was telling us, look, if we use solar energy it cost to us. And I'm talking about many years ago, that would be $1 for a cubic meter of water. All that area, the problem, it has a seaside next to it. I don't know if you have estimated this, but the amount of water vapor generated in that area is incredibly higher to the deficits that could occur. So there has been attempts by the Mexican government, or at least the project, if we have the water, let's use solar energy. Why don't we invest in desalting the water and irrigate? So the excess, the surplus, send them to Chihuahua, inject them, and you solve the problem of the Chihuahueños. So these are big things that sometimes are being faced in front of a short-sightedness, or maybe it's a false expectations. Since it is your area, I would like to know your opinion. Thank you. First with the first one. I started carrying out a regional modeling in a scale of 6 kilometers, approximately in 2015, 2016, and for me this was a mental transformation. Because I am a basin hydrologist, I carry out modeling of a scale of 10 meters, 5 meters, 1 meter. How is it possible that I can run my model, that I run it for the Rio Sonora, that is 26,000 square kilometers, and I need a supercomputer? How am I going to run it for other countries? Impossible. It will take my whole career to go to the numerical methods that I developed here. So we adopted this other model, and we are seeing it with a critical eye, because we know that we are talking about huge cells. This model has no interaction of a cell and another on the soil. The model, our photographic profile, a huge column of 6 kilometers times 6 kilometers next to the other, but there is an elevation differences. You have the leaking from one area to the other, and it goes to a sewage area that is not coupled to the rest of the system. And to get to these scales, we have to carry out huge simplifications, and therefore we have carried out comparisons of the vertical flows, and from the aggregation of a big basins in Rio Colorado. When we measure different points, we go the model and the measurement. I already carried this out because not all the processes are represented in the model. Nevertheless, for the study, that is the best available tool in the whole world. I regret to tell you that, but that's the way it is. But we had to improve it because the original model assumed, you have seen this in the atmospheric sciences as well, the solution of the big leaf approach. That means that the canopy covers all the cell. And that is also the forest in Washington, but it's very incorrect when the water leaf uses a small fraction. And that type of improvement has helped us to reproduce vertical flows with a better trust. And second part of the question, I'm fascinated with this topic. Desalting water in the Sonora Desert, its transportation to agricultural and urban areas, that would be a radical change of systems. A hydrologist cannot solve it. It needs one hydrology and energy engineering, a hydraulic engineer, public policies. Public policies are important because solar energy in the US has a boom. There are lots of incentives. But in the side of Sonora, there is no boom. It is not due to a lack of sun. The technology of desalting water is very expensive, so expensive that we have a desalting plant in Yuma that has never been turned on. It was completed in year 94, and part of the Treaty of Rio Colorado between the US and Mexico, the Mexican agricultors were receiving water with too much salt content. And the answer to that was to build a desalting unit. Very expensive. It was expensive then and it is expensive now. Instead of doing that, they built a new channel, and the more salty waters go to Santa Clara. They have made a cultural legacy of a channel of salty water that nobody wants for agriculture. I tell you that as an example. It's not only in the technical part, but the interaction of our public policies and the interactions of the two countries in their treaties, the commerce agreements or the water agreements for the border, where we need to have perfect conditions to carry this out. But I can imagine a future with the Sonora Desert producing electricity that helps us to move water. Instead of using fossil fuels, we use that energy that maybe flourish in some agricultural areas when we could reload the aquifers. I can imagine that. That is in the possibility of the 40 years that I still have to live. 40 years before, what was there, what was not there? Let's think about it. Very good. Any other question? Congratulations, Enrique. I am very happy to see you again. A first part is consistent to the chemical composition of water. It's very interesting, the balance that you are presenting. Nevertheless, there are components that is avant-garde to study them now. And it is also valid in the nitrogen. So we get involved in the model that you are talking about. And a very important aspect is naturally how nitrogen moves in different atmospheric systems, but the other contribution we have is due to agricultural activity. We may be using nitrogenated fertilizers without the proper surveillance, and that could be contributing. Based upon your experience, how did you suggest that in a given moment we can include other part of a chemical composition for the water, and the other is more our social point of view? It called my attention, the photograph, that it's in one side the military camp and there is no population density, and on the other side completely populated, even irregular settlements and social problems that are huge. In this case, if we continue along the borderline, there is a total impact because we continue with that line. On the one hand, there is even green places. On the other side, you have a maquila industry, and many times the industry on the other side of the industry operate with very stringent condition in environmental terms, but not on this side of the border. And if in water it is complicated to control it, and there is a trans-border flow that we do not even see, how do you consider this, and what suggestions would you present in this TEMEC? And previously there was the Association of Surveyors of Water of North America. Excellent comment, and it is very good that you join our forces and you help me answer the questions. In the cycle of nitrogen of agricultural areas, we know that in Sonora we have studied it quite a bit. In Yaqui Valley, Stanford had a project for 10 years, essentially there, how much fertilizer is being added, where nitrogen goes to, how it transforms in the soils in the channels, and it is transported by the channels themselves and the water surplus, and how it goes to the Sea of Cortez, and how the phosphate create an algae bloom. And this algae bloom can be seen from the outer space. So the Sea of Cortez, we have cut Rio Colorado there. We have all of that. What was suing a greater part of the west part of the continent, not the settlement, not what it was transported by the settlement, not to the water. And nevertheless, we have built agricultural areas next to the Sea of Cortez that add water. But water with fertilizer and other things. What are we doing in the Sea of Cortez? Who is the owner of the Sea of Cortez? It's a world legacy, not only for Mexico. Maybe the ocean limits indicate it is Mexican, but it is the legacy of mankind. And we do not consider it like that. Not there, not here. In December, we find the first cruise in Sea of Cortez. It starts in Puerto Peñasco, and it's going to be for 11 days going down to Mazatlan and back. The industry of tourism will be exploiting the Sea of Cortez, and that is a binational effort. Here, U.S. people are helping with the necessary infrastructure in Puerto Peñasco in order to have the boom. What will happen with the Sonora Desert, that is the land border of the Sea of Cortez? We have to think about it. On the side of the air quality, wow. Let us look at the problem of Mexicali and Calexico, and both parts produce agriculture, but in the area of Mexicali it produces lots of dust. It's the most dusty the city I've seen in my whole life, and the wind takes this dust here and there. Who owns the problem? Whose problem is that? Maybe somebody from Mexicali is listening to me, but I love Mexicali, but it's very dusty. Mexicali people tell that themselves. I don't know how to tackle that, honestly, but that must be present in the debate. It must be in the debate. Maybe it is a more local problem than the water problem. Air pollution, maybe, it depends. You tell me if that is transported 1,000 kilometers as water vapor does, or if one of these pollutants are driven by rainfall. Definitely we have to consider the topic, and not only that, the air quality and the availability of water go hand in hand, because I am using irrigation in my urban area, and I will have a dust production, among other things, and I think these things are linked. And I want to participate in that league, how to use water or not, how the heat areas make an influence or not in the atmospheric pollution. We got a question through the Menti, and it says, what is happening with the water that it does not reload the aquifers, and how does this affect the ecosystem? Okay, the water that is not reloading the aquifer because it was used for irrigation or for urban uses, well, that water is 10,000, 12,000 years old now. It is being used. We drink it, it goes around our systems, it goes to the treatment of black waters, and it depends. Sometimes it is taken back to the rivers or to the coast areas, and that process is evaporation. And underground water is evaporating many times because we are talking about an arid area. Wherever you put water, in my house, the towel is not wet, not even for 2 hours. You get out of the shower, you put the towel there. In 2 hours, it's absolutely dry. I do that in Puerto Rico, and the towel, it will be wet for 3 days. Exactly. So that is a wrong answer to a wrong question. Thank you for this extraordinary presentation, and as always, I thank this Center of Excellent Research for the summon to come and listen to these great men of study and research. And my question, out of so much information that you told us it's public information, guaranteed and compared to official information. When you carry out this effort of explaining so many data, I have a question on the presence and the contribution of NAFTA. We are waiting for its enforcement, and due to the approval in the US. In the vision of your studies, have you considered carrying out these proposals so our development, national development, especially in the agricultural sector, could be defended? Because my question is this. I have this question. In the US, the greater the urbanization, they save water. And in Mexico, when they progress in urbanization, water is more spent, more wasted. How is that? And which could be the effort of the Mexican government and research institutions, such as other ones you work for, could get closer the decision makers, so we can make a more just. So you have hit the core of the problem. How do we take scientific research and the research and engineering that is produced in the world, UNAM, for example, and we make them accessible to the use in society for the decision makers of the agencies, the political class, and the media? How do we accomplish this? Not only that, how do we train the students of undergraduate studies and postgraduate studies can be the vehicles of science towards the public? That's a great challenge, because if we remain in our own sphere, this makes no influence in the conversation among the countries. So we need to be a bit more skillful with the mass media. I'm impressed that this is being disseminated in Facebook Live, and I'm tweeting while I talk. We have to do that. We have to promote what we learn. We have to discuss respectfully with our peers when we have differences, but to try to get to a consensus result, because the big problem we have is cacophony. If I'm a decision maker and if I ensemble 10 experts, I can promise you that I will get 10 different results. How can we accomplish a consensus to be able to help society? That's what I do. I come to Mexico to talk about a Mexican topic without being Mexican. We publish because we are free, we are willing to collaborate. We make a call for collaboration for the Mexican society. That's the first step. We have to do joint projects. We have to find philanthropic societies that support. And we have to continue on the way. And you do not realize when the work that you did 10 years ago started provoking changes in public policies. You get a surprise. They call you, hey, I heard and I read that you did something in Rio Sonora. We've done lots of things in Rio Sonora. It's esoteric until it happens. That disaster of the mine. And the hydrology of Rio Sonora is no longer esoteric. I didn't participate, but lots of people who are hydrologists and who worked in Rio Sonora could contribute to the topic from the academic point of view. And maybe we do not see the result of this work in the current negotiation that will be very fast with two new governments and governments that are changing the status quo up to a certain extent. But maybe in the next round we have a little bit more time in order to contribute to the dialogue. We have to participate, we have to go to the meetings, where the discussion is diplomatic or political, as scientists, in order to inform them of what we have found. It is our responsibility to mobilize the knowledge that we have produced to society. It's not the responsibility to come to us. It is our responsibility to go to them with all the necessary respect. Of course. I think we have got to the end. We already took additional 20 minutes. And the professor will be here to answer the questions or to talk to them in the place of a video conference from 3 onwards. So you are invited. Casi no lo oigo. Thank you so much.